Hello, Math 112 fans. Going to make a short video on section 13.4, consumer and supplier surplus. We're also going to do this in class, but this is a little supplement for people that want to get ahead or just want to see some more examples. Watch my previous video if you don't remember anything about the supply and demand idea. I just talked about how we call that the market equilibrium, blah, blah, blah. Okay, so imagine market equilibrium is at $425 at that selling price. At that selling price, the amount that we produce and sell in the marketplace will be the same. So there's a couple perspectives, a couple additional measurements we can make in an economics course if we think the curves are accurate about what's going on, because some people were willing to pay more. So here's the consumer piece of it. You went into the store and you were willing to pay $500. You got in there and the price was only $425. Now, if they could have known that, they would have raised the price when they saw you coming. So it's $75 that they lost, or $75 you gained that you thought you lost. Okay, so we say you can visualize that right here. I've got a little thing showing. You're part of this group that was willing to pay more. All right. So in econ, and I don't claim to be any sort of expert on this. Again, I'm just teaching you the math needed to compute these things. So trust your econ teacher over me. But we would like to add those up, so to speak. So people, maybe someone else watching this, if anybody, I don't know why someone besides my Math 112 students watch this, but if you're watching this and you want to know, you might start to think about calculus, like what are these? I want to add up all of these heights. That starts to sound a lot like an integral. Okay. So ultimately, we're going to turn it into an area question. And we're going to ask, what is this area? And that will give some sort of measurement. We can compare with other situations with how many people in total, in terms of dollars, were others willing to spend more. Okay, so that gives this idea, this measurement tool. It's just one extra little piece of this that you can think about when you're looking at a given commodity or something. The sum of all the monies that some consumers are willing to pay over the market equilibrium for a given product is called the consumer surplus. And you can see the definition there. And it's that area. Here's where the calculus comes in. Using the tools we've developed, we can find that area. It's actually no problem. So you might think about what the formula would be. Okay, I'm going to get rid of this. And let's just think about it a little bit. So in a given problem, you would have the two curves. You would know this value. I'll call this x1 just to sort of signify it's a particular x, and p1. And that's this market equilibrium point, x1 comma p1. Think about what the area would be. We have this tool that finds the area under something. So for example, this tool, and this is what we'll do in class, the integral from 0 to x1, whatever it is. If that's too hard, for us, let's put some numbers in here. Apologies, I don't want to be too general. Let's say it's 100 items, and let's say it's $400. Okay, let's simplify this thing a little bit. And let's say the market equilibrium, I will call that f of x, so we will talk in generalities. So you can do the integral from 0 to 100 of whatever your function is, and it will tell you this area, which is not what we want. It'll include stuff we don't want. So what we need to do is remove this box. And in class, I'll say, well, what's the area of that box? The area of that box is 100 times 4. We're going to subtract this from this. So 400 times 100. That's the formula. So I intentionally was hiding it with my head here. But there's the formula. And it's not that complicated. So that's, we're done with, the moment I write this, we're done with the econ part. I'll save that for when you take your econ course. Just a measurement, one other measurement of consumer surplus. And that's what you're going to do in the homework. These numbers you'll either find or be given. You'll be given the formula, and then it's just a calculation. It's not that bad. Let's see if I'm lying to you. So here's the homework. Make it a little smaller. Move it over. Some questions, they tell you the market equilibrium. Like this one tells you the market equilibrium is at 8. So let's just look at that first question. I'm not going to compute all the homework, but let's look at it. So the first question says the function for demand, which is the f of x, is 89 minus x squared. The price at equilibrium is $8. And then it says compute this. You might say, well, I don't know what the x value is, but you can figure it out. This is the price. So, when we talk about a demand curve, it's relating the price and the quantity. So you do have an initial job to do, which is to figure out the x, but that's fairly easy to do because you have 8 equal to 89 minus x squared, and then you can solve. You're going to get x squared is 81. X is 9. So now we know this is 9 and this is 8. And the rest of the problem is going to be calculation. So if you don't know what I did there, they told me the price. They don't have to tell you both the x and y, because if you know one of them, you know the other. Okay, let's erase that. So then you compute. You compute the area under the graph. So it's going to be the integral from 0 to 9, because that's the x value, of 89 minus x squared dx. And that's going to be the total area underneath all the way down to the axis. And then you're going to subtract the area of this box, which is the P times the Q. So it's going to be 8 times 9, or 72. So do your practice. The main point of this section is for you to see another application. So use your antiderivative skills. Antiderivative, plug in 0 and 9. And when you're done with all of that, subtract 72. Enter, done. So that's what you're doing on these questions. Question 2, you're going to do the exact same game, but before you start, you have to find the market equilibrium. Watch my previous video on that. Question 3, same thing. Question 4, they tell you the price. So that's the same as the one we just did, but they tell you supply. Okay, so now we're going to talk about that. All right, hide this for a second. So the other measurement, now you can probably guess, is, well, what can we say about the producers, the people in the bottom half? So let's get rid of this and grab this. So we can talk of the same thing in terms of the manufacturers. There are some manufacturers that were willing to manufacture it for a lower price. So same sort of thing. There's some that, even though the market equilibrium, let's say, was 425, there were some that were willing to produce it at 380, that price. So they were willing to sell it for less. How many people were willing to sell it for less in this given commodity or industry? So that's this. So we're going to add up all those things. So here's another chance to play this game and to think about how an integral can help us. So this green area we can get from an integral. That's going to be the integral under the supply graph. But that's not what we want. We want the orange area. So how is this one different? We can find the area of the box the same way we did it before. And we can find the area under the graph using an integral. But this time we would like to do the box minus this area. Right? So we would like to get this area and then subtract this area. And when we do, it'll be just this orange area I've shaded. Okay, so the formula looks a little different. We find the box minus the supply. All right, so let's pull that formula up. Here's what it looks like. Get rid of this stuff for a second. Okay, here's my notes on this. Just trying to keep everything in one spot. It's a poorly planned thing. I won't do that in lecture. Okay, so there's our formula for what this is. And that should make sense, based off our little discussion there. Wasn't much of a discussion because it's just me talking. Okay, so there's this. We're trying to find that area. This first part represents the area of that box. So this thing. This is X1, this is P1. And the second one represents the area under the curve here. And we subtract that from the box and it gives us our producers or suppliers surplus is what we call that. Okay, you can also use the formulas, but I just wanted to talk through where they come from. So when you get to these homework questions that say, here's the supply function, what's the supplier surplus? Sorry, I made it go away. It's the same game. And you can see I was calculating one to prepare for this video. Your numbers are going to be different, but number 5 says, what's the supply? If the supply function is this, so they tell you the function, the g of x, so to speak, is 15e to the x over 3. This is question 5. And it's asking you to find this piece. And they're telling you to do it at 15. So when they're saying that, I wish they would say it a little better or say that it's equilibrium. They're telling you this is 15. I would never give you a point that wasn't equilibrium. So number 5 was the one I liked the wording the least when I looked through the problems. So they're telling you that 5. So you have a couple things you need to do. So this is like your P. This is your function. You're going to have to plug in the 15 here. It's going to be kind of a messy number, but that will give you the corresponding P. Hope that makes sense. And then what are you going to do? Once you have that value, which is going to be 15e to the 15 over 3, you're going to multiply it times 15. So let's sort of follow through the formula. This is what we're calling P1. This is what we're calling X1. And that's the area of the box. And then you're going to subtract the area of the integral. And the integral is going to be 0 to 15 of this. And so here's a chance to do an integral. My experience, students often get this integral wrong because when they go to plug in 0, they assume it's 0. It's not 0. But it's going to be fairly quick. Maybe it's good to note that this is 15e to the 1/3 x. And so when you integrate, remember you flip that number out in front, so it's going to be 1 over 1/3. So I think it's going to be 45 e to the x over 3 evaluated from 0 to 15. You're going to plug in the 15 everywhere. And what I'm computing right now is the thing I'm going to subtract. I'm doing this piece. I'm just doing it in the margins. So we're going to do 45 e to the 15 over 3 minus 45 e to the 0. I've been surprised at how many students don't know e to the 0. E to the 0 is 1. I went back and looked, and that was in math 111 many times, but now is time. You could need to convert this to memory. So your final answer will be, you'll put this in here, you'll subtract, you'll see what you get. And it says round it to the nearest cent, which I did. I got that 26,759.37. These are going to be big numbers because it's the total amount of money in the marketplace that Supplier sort of left on the table. All right, that's what that section is. It's a nice opportunity for us to practice integrals. For us, it's just another place to see an application of our tools because we're doing calculus tools, but all in this applied setting this term. But I hope that helps people that want to see some more examples.